from areas where they could cause damage and deal with it elsewhere. You know, the SUDS approach suggests you should always deal with that locally. That might cause damage to property. You might be able to deal with a large volume of water away from a housing estate, for example.
Well, thanks, Caspar. It is kind of worthwhile remembering that, you know, we need to be a little bit more, as you say, circumspect, I think, about our use of sustainable urban drainage, maybe not necessarily in all conditions, and pipe drainage has its place. But there's this phrase, the 1-year and 100-year return period events. 1 year and 100-year return period events. What does that mean?
That means that that's the time interval between two events that could possibly occur. For example, between two floods. For example, in 1 year, that's the time that a flood or a storm or an earthquake can happen in 1 year, or in 100 years, which means with the possibility of 1%, means that once in 100 years, an earthquake or a flood can happen.
Right. So it's a statistical chances of an event occurring.
Measurement, statistical measurement.
Okay. And then there's the 100-year 6-hour event.
It means that 1 in 100 years, that event can occur with a duration of 6 hours.
Right. So we're talking about, in this case, rainfall patterns, say, causing X number of millimetres of rainfall over 6 hours, and how frequently that might occur within 100 years.
Exactly.
Fine, okay. Well, since we're getting into technical territory, let's try and sum this up if we could, please.
The revised code will push for the peak water runoff from a site to be no different after the development is built from before. That is, the peak water flow off the site should be the same as if the development had never been built. Now, the only exception to this rule is that if the pre-development site had a peak flow rate of less than 5 litres per second at a given discharge point, then the post-development site is allowed to have up to 5 litres per second. And this is to ensure that the water flow is sufficient to flush the system. Secondly, the volume of surface water runoff must also be the same as before building. However, if this isn't possible, then the excess must be retained on site and provided with controlled filtration. Or, in certain circumstances, the peak flow rate must be limited to the maximum mean annual flood flow rate of the pre-developed site, or 2 litres per second per hectare, whichever is the greater. As previously mentioned, whatever the calculations, a flow rate of up to 5 litres per second should be used to ensure the system is satisfactorily washed out.
Well, that was meant to clarify things, but still as clear as mud in some degree. Could you maybe try and untangle some of this slightly overcomplicated data?
Well, in order to put it in very simple terms, what actually the two criteria that are in the code, what they're actually trying to say is that we are trying, now with the use of the sustainable drainage systems, we're trying to mimic the natural way in which rainfall drains in a natural system. So, and that's why we have the comparison between the pre-developed peak flow rates and the developed flow rates and volumes.
So, Caspar, it seems, I mean, in an ideal world, we're talking about no more water leaving the site after a development has been built than before. So, the same amount of water leaving a site after you've built a house, a roof, a drive, or whatever, as there was before there was anything built on it. So, again, how, in your view or in your experience, how practical is that, how difficult is that, and how beneficial is that?
It's hugely difficult because, of course, you have lots of hard surfaces once you introduce housing or buildings. So you don't have the natural drainage of things just going into the soil. So, I mean, again, I would say sometimes it's practical. If you have an obvious route whereby you can get that water back into the groundwater on site, then fine. But there are many circumstances when that actually doesn't make sense, because water will flow away very rapidly over hard surfaces. And actually you want to look at how to remove that water.
But what about, I mean, because you have to talk about the geological conditions of the site as well, haven't you? So, you know, if
Yes.
you are talking about building on a site with a high water table, then presumably allowing water to soak into the ground isn't necessarily going to be a good thing.
The geological thing